All right, so starting off with 1.1 angles, this is pretty stepping back into geometry. So like going over some terminology and things that you should have learned in your geometry course, and with a little more in-depth information, okay? So to start off with, in geometry, basic terms is two distinct points determine a line. Do you remember that? Yep, 2 points make up a line, okay? A line segment has a beginning and a end. That's what's the difference between a line and a line segment. Lines go on forever in both directions. Segments have starting and a stopping, right? Array goes on forever in one direction, okay? Does all that look familiar from geometry? Lines, segments, and rays, okay? All right, now angles are made up of two rays that meet at a point, okay? It's two rays that share the same endpoint. Okay, that's how you have an angle. The two rays make the sides. All coming back. Am I good at the pace that I'm going? All right, cool. Okay, that common point is called the vertex. So that is the vertex of our angle. Boom, bam. All these words we've heard before. Okay, your angle measure is generated by a rotation about the vertex. Okay, and when you rotate, we determine our initial side and our terminal side, okay? So when we're rotating, where you start is called your initial side, where you stop is your terminal side, and that's what creates the angle itself. Yes? Okay? All right, positive angles. Positive angles, you're going to rotate in a counterclockwise motion. That creates a positive angle. Okay? Negative angles are rotated in a clockwise motion. Does any of this sound like, oh, she's making it up? All right, good. Oh, well, it's there. It's from geometry. I know, I said it. These are all geometry terms that we have to bring back and make sure we're comfortable with, okay? So yeah, positive angles, counterclockwise, negative angles, clockwise, all right? Now, the most common unit for measuring angles is in degrees, correct? That's what we're pretty comfortable with. A full rotation is a 360-degree motion. Okay, and oddly enough, we call that an angle. So this is a 360-degree angle that you're looking at. Make sense? Okay, now, 360th of a complete rotation gives an angle whose measure is 1 degree, okay? What this leads us into is called radian measurements, okay? So that's called a radian measurement, which we're going to also talk about a little bit later, or just keep that in mind that when we start using another term of measurement, it's because we're talking about in terms of 1 over 360. All right, classifying angles. Do you remember these guys? All right, if I'm between 0 degrees and smaller than 90 degrees, I'm a cute little angle. Yes. If I am equal to 90 degrees, I am a right angle. If I am greater than 90 degrees, but less than 180 degrees, I am in an obtuse angle. And if I am equal to 180 degrees, I am a straight angle. Okay, acute, right, obtuse, and straight. Yeah, still with me? All there? Okay, so for an angle measuring 40 degrees, find the measure of a complement and its supplements. We're going to talk about a complement. If I am a complement to an angle, does anyone remember what that means? Equal what? Anyone remember?
Or 180 or 60?
It's 90. Complements. So complements are angles are going to equal to 90 degrees. Supplement means that your angles are going to equal to 180 degrees. You remember that? Okay, think about it in alphabetical order. So C, S, and then numerical order, 90, 180. So complement angles are going to equal 90. Supplement angles are going to equal 180. Okay, so if I have the measure of 40 degrees and I want to find its complement, what am I going to do? Subtract it. So its complement is going to equal equals 90 minus 40. So my complement is 50 degrees. Make sense? All right, if I want to find the supplement, I'm going to do the same thing, but this time with 180. So we have supplement equals 180 minus 40. So that's going to give us 140 degrees. Do you feel confident in finding complement and supplement at its base form? Yes? Okay, cool. All right, let's change it up. Now, what do we have here?
Right angle.
We have variables and a right angle. So that means there's something unknown, right? All right, but we do know because it's a right angle that this means that we have 90. Because it's a right angle, we know that this equals 90 degrees. So therefore, these are complement angles, right? And because these are complement angles, that means together they have to equal 90. Is that something we can solve?
Yes.
Oh, you saw nothing. I added it already. Blame it on the Dayquil. We can easily solve that, right? So now we're left with 90 equals 9x. So what is x? So x equals 10. So now can I find the two complement angles? Yes. So we have 6 times 10, which equals, and then we have 3 times 10, which equals, I don't know why I keep writing 9. You saw nothing. It's like my brain wants them to be together. Okay? That's where we get up a notch. So that's where you take complement and supplement up, is by adding in a variable and then having to tie in the algebra. Was it terrible? No, you survived. Good job. All right, cool. Okay. All right, and we knew that we were doing complement because it was a right angle, and right angles equal 90 degrees. Cool. All right, what about these two?
Straight line.
It's straight line, it's straight angle, which means 180. So go for it. Solve and these are gonna be what kind of angles?
Wait, supplement.
Supplementary. You know, me, I'm hearing the question. Hopefully this does feel like a geometry review right now, because that's what it should somewhat dust off those geometry cobwebs. I can't say what you should have learned in geometry because I'm not a geometry teacher, but I know the content. I can't guarantee because I wasn't taught. All right, so like we discussed, these are supplementary angles because they're on a straight angle, and straight angles equal 180. So we know that together, 4x plus 6x equals 180 degrees. So that gives us 10x equals 180. We divide by 10 and we get 18. So x equals 18. So to find our two angles, we have 4 times 18, which is 72. And then we have 6 times 18, which equal doable? All right, perfect. Okay, now we're gonna talk about degrees, minutes, and seconds. And I don't think in high school geometry, you focus a lot on converting between degrees, minutes, and seconds. And so this is gonna probably be a little more new information, okay? So just keeping that in mind. Now, when you're talking about angle measurements, it goes along with our time because time is rotating. Think about it, it's a clock, right? So there's rotations tied into that. So 1 minute is 1/60th of a degree. And when we write that, we write it like this. Okay, in terms of angle measurement, a minute is written with an apostrophe. So 1 apostrophe means 1 minute. So if I've gone 1 degree, I've gone 60 minutes. Okay, after minutes, well, before minutes come what? Seconds. So 1 second is 1/60th of a minute. And how we write that is with double apostrophe. Okay, in math, you may hear instead of saying apostrophe, we call them primes. So we have double prime and single prime, 1 prime. So basically what we're doing here is just converting between different measurements of units. But these are the rules that you need to make sure you know and are able to comfortably convert.
Is that prime?
Yeah, instead of apostrophe, we say prime. That's an English term. All right, did we get our conversion rules written down? Are we ready to apply them? Ready, set, go. All right, so what happens here? Well, what ends up happening here is we're gonna be adding. We can all add, right? Simple enough, yes? Okay, so just like any other time you add, you're gonna add like terms together. So what this is saying is that I've gone 51 degrees and 29 minutes. That's one angle measurement, right? 51 degrees and 29 minutes. The other angle measures 32 degrees and 46 minutes. And we're gonna add those two together, okay? So I'm just gonna rewrite it as 51, 29, and then we have 32 and 46. So we're adding them together. I'm adding my degrees and I'm adding my minutes. Does that make sense? So when I add together, we have 83 degrees and we have 75 minutes. Because I have 75 minutes, I can regroup that into a degree. Does that make sense? Does this make sense? I have exactly. So 75 can be regrouped as 1 degree and 15 minutes. Yes? Do we agree? So then my final answer is actually 84 minutes, 84 degrees and 15 minutes. I added the degree. So I can regroup 75 because every 60 minutes equals 1 degree. So 75 divided by 60 is 1 with the remainder of 15. So now I'm adding 83 plus that 1. Because it's a degree. Was that terrible? All right. So that's for adding. You're going to have to regroup in the end. For subtracting, sometimes you have to regroup in the beginning. Does that make sense? Because right now, can I subtract? Do I have any minutes for me to subtract? No. So instead of writing this as 90, we're going to write it as 89 degrees and 60 minutes.
Wait, what? Why? Or like, what did you take away the?
I needed to take one of my degrees and turn it into minutes. So think about when you're trying to give someone change, right? If I'm giving someone change, I need to sometimes take my dollar and break it down, well, my $5 and break it down into dollars in order to give someone change, right? So if I had a $5 bill, but I need to give someone a dollar, I'm gonna take that 5, break it into dollars, and now I can give someone change, right? Same thing happened here. I took my degrees, I broke it down, I changed one of my degrees into minutes because 1 degree equals 60 minutes. Or think about it, it's basically saying $1 equals 60 cents, but that's not correct, but I don't know how else to do it.
If we were adding, we'll just leave it.
Yes, because in the end, adding, you don't regroup into the end. Subtracting, you have to regroup in the beginning. So now minus 73 degrees in 12 seconds. Can I now subtract where I need to subtract?
Yeah.
So 89 minus 73 gives me 14?
60.
Oh, yeah, 16. I was like, what? And then 60 minus 12 is going to give me. So my answer is 16 degrees and 48 seconds.
Minutes and seconds. That's what I'm saying.
Minutes, sorry.
Oh.
Did I say seconds? I'm sorry. I just took Dayquil. All right. Yes? Yeah? Are we okay? We're good? All right. Let's go a little. Now, you're gonna need a calculator. You're gonna use the calculator, don't worry. If you don't have a calculator, grab it. He's like, All right, so if we're converting and it's asking us to approximate this to degrees only, what you're doing in the calculator is you're rewriting each one as a fraction of time. So I'm going to go back really quick. So remember I said it's important to write this down. So we know that if we have 1 minute, that means we're taking the degree and dividing it by 60, right? If we have 1 second, we're taking the degree and dividing it by 3,600 or whatever, okay? So you're essentially doing the same thing with the numbers that are given. So if I have 74, that's our degrees, we're gonna leave that alone. Plus, and we're going to take this and we're dividing it by 60, because that's what the degree term would be, divided by 60. And if you have seconds to find the degree, you're divided by 3,600. And this is going to give us our approximate degree measure.
Are you converting it on?
You're converting everything into degrees. So if I need to convert everything into degrees, if I need to change this into a degree, I divide it by 60. If I need to change my seconds into degrees, I divide it by 3,600. Okay, so now we're going to go to our calculator. Welcome back, Sylvie. We have 74, 8 divided by 60, plus 14 divided by 3,600. You're gonna write the whole thing in there. And you hit enter. And it's gonna give you your approximate decimal. And it says round to the nearest thousand, so our nearest 3 decimal places. So we get 74 and 137 degrees. That's it. You just gotta remember the converting rules. So if I'm converting a minute, I'm dividing by 60. If I'm converting a second, I'm dividing by 3,600. Okay? And then you let the calculator do the rest of the work. Was that terrible? All right. Now, what if we want to undo it? Okay. Now we're going to undo that. Okay. So when we were doing it, what did we do? We multiplied. So we divided, we didn't multiply. So in order to undo division, we have to multiply. So we're going to undo this. So we already know that we're at 34 degrees, right? Agreed? So now we're going to start off with the decimal. So we're at 0.817. We're going to first find out how many minutes that is. So 0.817, instead of dividing by 60, we're now going to multiply by 60. And that's going to tell us how many approximate minutes we have.
I'm writing.
Yeah. So we already know our degrees is 34, right? Then we're going to use the decimal to figure out the minutes and the seconds. So what we just did was division. So to undo that, we're going to multiply. Yes? All right. So we're going to do 60. Doesn't matter how you put it in. And we get that it is 49.02. So we're now at 49.02 minutes. Now you're going to take the decimal of the minutes to find your seconds. What did we multiply to get that? 3,000. Minute we divided, sorry. So we're going to multiply. And that's going to tell us our number of our seconds. I did that wrong, guys. Sorry. There is only 60 seconds. 60 seconds. This is just supposed to be 60. My bad. I apologize. That was your teacher on her slow motion. And now we're at 1.2 seconds.
But if we're finding seconds, why don't we use 3,000?
Because it's not from the degree, we're finding it from the minutes. And one minute equals 60 seconds. So my final answer is 34 degrees, 49 minutes, and 1. So I don't know what they're gonna ask or want you to write. My teacher, we just wrote the 1, but if on your, I think you're right, ignore the 9. On your, what's that place called? Pearson, you're in my lab, thank you. If it asks you to round, then just make sure you put that rounding. So it'll be degrees, 49 minutes, and 1.2 seconds. Just read the little blue instructions to see if they want you to round to the nearest whole second, or if it wants you to round to the 10th of a second, or. My little marks got weird. Make it a little pretty. Okay. All right. Sorry about the 3,600. Let me write that. I was thinking in terms of a degree and not in a minute. But all you're doing is taking what's left over and multiplying. Left over, multiply. Left over, multiply. All right. So here we had everything and broke it down. Yes. Then that's where then there's no seconds.
Okay.
Yeah. So like if there was no decimal remaining, then you would be like, oh, well, there's no seconds. Okay. How do we feel about degrees, minutes, and seconds? All right. Now, standard position. So we're going to talk about standard position. This is when you're on a coordinate plane. Just make sure we're good with our coordinate plane. Coordinates are labeled in counterclock order. So you have quadrant 1, then you'll have your quadrant 2, you have your quadrant 3, and you have your quadrant 4. Okay. Your initial side always starts on the positive x-axis. So your initial side is always your positive x-axis. And your terminal side is the one that rotates through the quadrants. Ringing bells, sounds familiar? A little bit, somewhere in there, but pretty like math senses, common sense-ish. All right, so when we talk about our quadrantal angles, your quadrantal angles are your turns around the quadrants. So that's where you're going your 90, 180, 270, and back to your 360. Those are your 90-degree turns around your quadrants. Exactly. Okay, so when we are describing those, that's just all it is. So where am I at in terms of my terminal? So we know that a complete rotation is 360 degrees, right? And when we are describing them in relationship to our quadrants, we call those coterminal angles. So if I'm saying I'm coterminal to, these are coterminal angles, that's just saying that they're both from this nearest quadrant, this x-axis, they're both 60 degrees away. Does that make sense? Your terminal side is. You're not talking about the full circle. You're just talking about how far are they from their nearest x-axis. Okay, so your x-axis are going to be 0, 360, and 180, right? And when you're looking for coterminal, you're only saying how far are they from their nearest x-axis, depending on how it's asking you and which way it's rotating. And so they just literally are just adding on 360 because it's always going to be the same. You're just going over and over because they're going to always come back to that same terminal side. So how does that work? All right, so first off, let's say we have this angle of 908 degrees, and we want to find its coterminal angle. That means I'm not moving this side. This is going to stay in place, right? And I just want to know what is a number that I can still rotate to, but less than 360 and still end up here. So what you're doing is you're going to subtract 360 as many times as you need to in order to get to that value. So we're undoing that circle
To get to 188.
to get to a number between 0 and angle. How do I want to write this? An angle between 360. So you want your angle measurement between 0 and 360. And so all you're doing is you're subtracting until you get all the way back down to here. So if we're at 908, I subtract 360. And that would put me at what? $548. Am I between 0 and 360 yet? No. So I'm not my least positive coterminal. So I'm going to subtract another 360. And that's going to put me at 188. So my smallest positive coterminal would be 188.
Which is a lot of words.
Okay. Yeah. So that's why I wrote a little italicized thing. All you're doing is subtracting. So if it's asking you for your smallest positive coterminal, all you're doing is subtracting until you get between 0 and 360. Yeah, makes sense? All right, the reason why we're subtracting is because we start off with a big number. Now, what if I start off with a negative? I'm gonna be adding 360. So if I start off with a negative, my goal again is still for that angle measure to be between 3, that's an L by the way, 0 and 360. And so this time, if I'm at negative 75, instead of subtracting, I'm gonna have to add 360. And that's gonna take me up to my 285. Does that make sense? And this is this satisfied? Am I between that? Yes. So therefore, my stopping point would be 285. There are an infinite amount of coterminal angles because the circle can keep going and going and going and coming back to that terminal side. But what it's asking me to find is the ones between 0 and 360. It's all adding, subtracting 360. That's it. Cool? All right. That picture wasn't supposed to pop up. So pretend you don't see.
Oh.
I don't know why it popped up already. Oh, there, I clicked it twice. You didn't see the answer. All right. Find the least positive measure of the coterminal for negative 800.
Oh, you want us to do
Mhm.
it?
I clicked the button to be that. You saw nothing though. Still practice.
Honestly, you didn't say nothing.
You want to notice the picture? Oh. All right. So you had to subtract a couple times, right? Did you end up with 280 degrees? Yes, got it. Do you feel confident in being able to find a coterminal? Cool. All right. Now, what if I wanted you to find from a angle between 0 and 360, could you find a coterminal greater than 360 and a coterminal less than 0? Could you do that? Yes, you could. Why? Because it literally is a formula. So when you're looking for coterminal angles, all you're doing is, if my coterminal is 60 and I wanted to find one's greater than 360, it's just how many times am I going to rotate from that 60, right? No, you don't get that? Okay, let's look at.
Divided by that 60.
No, it's just, I'm going to show you. So let's say you're at 60. So we're here on our chart at 60 degrees. And I wanted to know how many coterminal angles exist. That means that I'm rotating infinitely many times back to this same spot. Pew. What does that give me? And then I'm going to go again. Pew. What does that give me, right? Each time I come back to this spot is an N. Does that make sense? So if I'm trying to figure out, if I said, okay, I want you to find the coterminal of 60 degrees after 5 rotations.
Oh, you turned off?
You just plug in 5, right?
If they're trying to find the infinite.
If I've given you a value, if I said,
Oh.
I want you to find the coterminal, right? 60 degrees after 5 rotations. Instead of you having to add 365 times, do? You multiply, because what is multiplication? Repeated addition, right? Multiplication is repeated addition. So that's why the goal is to build up to a shorter way of doing it. Okay, so if my N is 2 rotations, 1 rotation, if I went reverse, could I easily just plug that in and find any coterminal that I need from that value between 0 and 360? Does that make sense? You sure? Yeah, this is going to change, but this is the rule that you're following every time. Yes, but 60 can change.
Yeah.
It could be 180, it could be 10, it could be 12. But as long as you understand that all you're doing is now saying how many ever rotations I've gone, I'm just multiplying that by 360. Or how many reverse, it's instead of a positive, it's going to be a negative because we're going clockwise instead of counterclockwise. All right. Yes. Do we need to test it out? Do you feel confident? Yeah. I didn't, I'll create one. I just didn't making sure. All right. So let's say, an angle coterminal with, let's do 15 degrees. We'll keep it small. So if I want to find an angle coterminal with 15, I can, instead of using 60, we're going to use 15. So this would become 15 plus 2 times 360. That means I've gone 2 rotations around that terminal side.
Will they tell us? Oh, we'll always do that.
Yeah. That's why I said your 60 is going to change. This part, the N 360 is what stays the same. But your 60 can change. It depends on the angle that they're asking you for. Okay, so then here, 15, only 1 rotation. If I had no rotation, it's obviously going to be itself. And if I go clockwise, it's going to be a -1, 360. And these are all still be coterminal because I'm just rotating from that same spot, coming back to that same spot. That's why when I said the 60 changes, but the N times 360 is going to stay the same. Oh, we almost finished. Okay, the only thing we're going to talk about is, of course, we have to always end with the real world example of how this is applied. And so we'll pick up here tomorrow before we get into 1.2. Cool. All right.
Was the only thing so far the introduce yourself, or was there more?